Look at any horizon on Earth and you'll see them. Towering peaks rising like the spine of the planet itself. Mountains. They feel permanent, eternal, like they've always been there, but the truth is far more dramatic. Every mountain you've ever seen is the result of a collision so powerful it reshaped the surface of an entire planet. And without them, life as we know it wouldn't exist. Not because mountains are nice to look at, but because they are quite literally the reason you have water to drink, air to breathe, and a climate that doesn't kill you. So how did they get there? And why are they the unsung heroes of life on Earth? Let's start with how mountains are born. It begins deep beneath your feet. The Earth's crust isn't one solid shell, it's broken into massive puzzle pieces called tectonic plates. These plates are constantly moving, grinding against each other at the speed your fingernails grow. Slow? Yes. But over millions of years, that slow movement carries enough force to crumble rock like paper. When two plates collide head-on, the crust has nowhere to go but up. It buckles, it folds, it crumples, like a car crash in slow motion. This process is called orogeny, and it's responsible for the greatest mountain ranges on Earth. The Himalayas? They formed when the Indian plate slammed into the Eurasian plate, a collision that started 50 million years ago and is still happening today. Mount Everest is still rising, about 4 millimeters every year. But not all mountains are born from collision. Some are born from fire. When tectonic plates pull apart, magma rises from the mantle to fill the gap. Volcanic mountains like Mount Kilimanjaro and the islands of Hawaii are built layer by layer, eruption after eruption from the inside out. Then there are fault block mountains, created when the crust cracks and massive blocks of rock are thrust upward while neighboring blocks drop down. The Sierra Nevada in California is a perfect example. A 400-mile wall of granite lifted by the Earth's own fractures. And Dome Mountains, formed when magma pushes upward but doesn't break the surface. Instead, it bulges the rock above it into a dome, hardening over millions of years into peaks like the Black Hills of South Dakota. 4 different processes. One result, stone reaching for the sky. But here's where the story shifts. Because mountains aren't just geological wonders. They are, quite literally, the reason life thrives on this planet. First, water. Mountains are called the water towers of the world, and for good reason. They capture snow and rain, store it as ice and snowpack, and release it slowly throughout the year. Nearly half the world's fresh water originates in mountains. The Himalayas alone feed 10 major river systems that sustain over 1 billion people. The Andes supply water to the entire western coast of South America. Without mountains acting as giant natural reservoirs, rivers would dry up, crops would fail, and civilizations would collapse. Second, climate. Mountains don't just hold water, they shape weather. When moist air hits a mountain range, it's forced upward, cools, and drops its rain on one side. The other side, the rain shadow, becomes dry. This single effect creates deserts like the Gobi, the Atacama, and the Mojave. It also creates the lush, rain-soaked valleys where civilizations flourished. Mountains redirect atmospheric currents, moderate global temperatures, and create the diverse climate zones that allow different ecosystems and different species to coexist on the same planet. Third, biodiversity. A single mountain can contain more ecosystems than an entire flat continent. As you climb from base to peak, you pass through tropical forest, temperate woodland, alpine meadow, and Arctic tundra, all on one mountain. This vertical compression of climates creates isolated habitats where unique species evolve. Mountains are biodiversity engines, home to nearly 1/4 of all terrestrial species, many found nowhere else on Earth. And there's something deeper. Mountains regulate the carbon cycle. Weathering, the slow breakdown of mountain rock by rain and wind, pulls carbon dioxide out of the atmosphere and locks it into oceans as sediment. Over geological time, this process has kept Earth's climate stable enough for life to persist for billions of years. Mountains are, in a very real sense, the planet's thermostat. So the next time you stand before a mountain, remember what you're looking at. Not just rock and ice, a collision of continents frozen in time, a water tower feeding billions, a climate engine, a cradle of life. The Earth built these towering structures over millions of years, and in return, they built the conditions for life itself. Mountains aren't just the highest points on Earth, they might be the most important. If this changed how you see the ground beneath your feet, subscribe, because next we're going even deeper into the forces that shape